Good afternoon, students. Welcome back to Ptsp online class. I hope you done well in the exams. And in this class, I am going to continue the topics which are left in the second unit. That is various distributions we have been studying with respect to the density function, probability density function of f(x). In the second unit, we have discussed the two important probability density functions or the distributions. One is Poisson's distribution, another one is binomial distribution. In the Poisson's distribution and the binomial distribution, we have studied its mean, we have studied its modes of operation, we have studied its variance. Mean is denoted with mu, we know that. And the modes of operation, that is mode 0, mode 1 and mode 2 we have discussed, and the variance we have studied with respect to the sigma. We left with the one more distribution in the second unit, that is called normal distribution. Before I am going to talk about the normal distribution, what is the necessity to study the normal distribution, even we are having the binomial distribution and the Poisson distribution in case of a probability density function. So in a probability density functions, that a signal will be there, that means a function will be there, in which by going with some conditions we are going to find where the density of the function is more and where the density of the function is less with respect to the probability we have studied. In studying these probability distribution functions, we studied these some other subtopics like the mean and the variance and the modes of operation also. But the problem with the binomial distribution and the Poisson distribution, and these two distributions are limited some particular signals only. That means we are limited to particular random variables only. This complete Poisson distribution and the binomial distribution when the random functions are discrete in nature. When the random functions are discrete in nature, then only we can make use this binomial distribution and the Poisson distribution. When we talk about the normal distribution, it can be applied for the continuous random variables. It can be applied for the continuous random variable. That means from one limit to another limit we can calculate. If one limit to another limit we can calculate the distribution function from here to here. That means what all the random variables are continuous in its nature with respect to the time and the amplitude. Whereas in case of Poisson distribution and the binomial distribution, that random variables are discrete in nature with respect to the amplitude and the time. So here the binomial distribution and the Poisson distribution is having some a limitation that can be applied for the discrete random variables only, and so that we are looking for the another distribution function that is named as it is a normal distribution. The main advantage of the normal distribution, just now I have explained, it can be applied for the continuous random variables. It can be applied for the continuous random variables. That means the distribution functions, that is binomial and Poissons, are discrete distributions, whereas the normal distribution is the continuous distribution. Normal distribution, this is a normal distribution, it is the continuous distribution. If you go with the continuous distribution graphs, you can take any example first. If you go with the analog signal, that can be like this. So that means what? If I know the limits here to here, if I know the limits, that is this is T1 and this is T2, I can calculate the distribution function, and that is nothing but the area under this curve I can calculate by making use of the probability distribution function by knowing the limits. Whereas in case of Poisson distribution and the binomial distribution, we can only calculate the probability density function at one desired instant of time only. By knowing the amplitude and the time, at the time only we can calculate the probability density function in case of binomial distribution and the Poisson's distribution. Whereas in the case of normal distribution, and it is a continuous distribution, so that we can calculate the probability density function if you know the limits from here to here. And that means what? Here this is a distribution, it is a continuous type of distribution, and you can go with the continuous type of distribution signals will be like this. These are the continuous type of signals, so that we can calculate the probability density function by making use of the normal distribution. And so that here we know that the probability density function that can be denoted with the f of x, probability density function is denoted with the f of x is nothing but it is a density function, and the density function, and if you wanted to calculate the probability of that density function, it can be denoted with like this. That means what? It is the probability of the density function. We know that density function is f of x, and we know the limits of that random variable. X is a random variable, and that random variables are limited from x1 to x2. So that I am making use of one graph, I can easily explain the normal distribution. This is about the continuous random variable graph. It is a continuous distribution. Random variables are continuously distributed from 0 to x, you can call. The continuous random variables, the random variables are continuously distributed from 0 to x. In this range, I am taking the 2.2 instant of time, that is x1 and x2, and you from x1 to x2 also, from x1 to x2 also, that random variables are continuously distributed from x1 to x2. It is having the continuous distribution. Whenever we are talking about the continuous distribution, it can be explained by making use of the normal distribution, so that the normal distribution is nothing but it is applicable for the continuous random variable itself only. So that the probability of a density function, we know that the density function is nothing but f of x. This is the density function. It is density function, it is a plot, it is a graph between the density function and the random variable. How the random variables are located in the density, we can come to know in the density function. So that this is f of x and it is x, and the probability of the density function, probability of the density function from x1 to x2, x1 may be anything and x2 may be anything, but they have to be continuous in its nature, then only we can apply the normal distribution. The probability of x1 less than or is equals to x less than or is equals to x2 is equals to, we can call it is the probability of that density function is given by integral x1 to x2 f of x dx is equals to, we have to calculate. For example, this signal is there, this signal is there, from this signal it is a continuous, this signal is there from minus infinity to plus infinity, minus infinity to plus infinity. If I wanted to calculate the probability density function from minus infinity to plus infinity, that means what? X1 is equals to minus infinity, x2 is equals to plus infinity. In such cases, you can have the probability density function of minus infinity less than or is equals to x less than or is equals to plus infinity is equals to integral minus infinity to plus infinity, that is about f of x dx. F of x is nothing but it is a density function. If you are taking the integral minus infinity to plus infinity of a density function, that will be equals to 1. This is a standard formula. That means what? Area under any impulse signal is equals to 1. That means what? We can have the signal is at only t is equals to 0, and the remaining all the values of t is equals to t not equals to 0, there is no signal. In such cases, we can have the integral minus infinity to plus infinity f of x dx is equals to 1. This is very, very important point. In case of normal distribution, if you wanted to calculate the probability density function at the all the random variables, so that it will be minus integral minus infinity to plus infinity f of x dx is equals to 1 only. And note that the probability density function is given by probability density function. This is a probability density function, and this f of x is a density function only. F of x is a density function. It is given by c is equals to e to the power of f of x is equals to c into e to the power of minus 1 by 2 into x minus a by b whole square, where a and b are the a and b are these are the the variables, this a and b these are the variables, whereas c is a constant. This a and b are, we can call these a and b are parameters, and these are the variables, and a and b are the parameter, and c is a constant. So that f of x is a density function, this is a density function, and this x is nothing but it is a random variable. It is a plot between the f of x and the x, so that all the random variables are distributed. All the random variables are distributed randomly in a continuous in its nature, so that this function is named as it is a continuous distribution function, and the continuous distribution function can be effectively explained by making use of the normal distribution only. So that f of x is equals to c into e to the power of minus 1 by 2 into x minus a by b whole square. A and b are the parameters. That means what, we are going to choose the values of those one, and whereas c is a constant. C is a constant, and this one is given by integral, that integral minus infinity probability. We can write this is probability of x1 less than or is equals to x less than or is equal to this one. This is c into f of x dx is equals to 1. This you can assume. Integral minus infinity to plus infinity, c into f of x dx is equals to 1, where c is a constant, that is c is equals to 1 by 2 pi under 1 by under root 2 pi b. We know that b is a constant, pi is a constant, 2 is a constant, so that if b is a constant, then always c will be constant. We are saying that c is a constant. Likewise, we can calculate the c value. C is equals to 1 by under root 2 pi into b. B is a separate one, not in under root, so that c is equals to, c is a constant, c is equals to 1 by under root 2 pi into b. That is nothing but it is constant from the density function, that is f of x. So that f of x is equals to, that means probability density function defined, that is f of x is equals to c into e to the power of minus 1 by 2 into x minus a by b whole square. A and b are the parameters, c is a constant, and the c is given by, it is 1 by under root 2 pi into b, and this is about the normal distribution description. In the binomial distribution and the Poisson distributions, we have studied the mean and the variance and the modes of operation. In this also we have to discuss about the mean and the variance and the particular modes of operation also. And the mean, if you go with the derivation of the normal distribution mean, you can get mu is equals to a only. A is a parameter which is there in the probability density function, that is f of x. Mu is nothing but mean is nothing but it is an average value, because this random value is keep on changing. This random value is keep on changing, so that in order to know the value of that random variable, we will be taking the average value, that is nothing but it is a mean value that can be denoted with mu, and that is found that mu is approximately equals to a. So that if you wanted to calculate the mean of the normal distribution, that is mu is equals to a only. And coming to the variance, that means variance is nothing but it is a sigma square. Generally that will be denoted with sigma only, but in variance we can have the sigma square. After doing some derivation, you will get sigma square is equals to b square. That means what, sigma square is equals to b square, means from this we can get that sigma is equals to b. That means what, variance in normal distribution, if you wanted to calculate the mean, that is mu, that is equals to a, and if you wanted to calculate the variance, that is sigma, which is equals to the b only. So that modes of operation will be different at the various values of x, because that x is not constant, it keep on changing, so that we can go with the two cases in case of modes of operation. One is x is a lower limit and x is a higher limit, that means x is equals to x1, and what is the mean value, what is the mode of operation, x is equals to x2, what is the mode of operation. With this case you can go with the modes of operation. Go with the mode is the value of x for which f of x is maximum. That means what, here you are taking x is equals to upper limit, that is x2, so that you are taking In such cases, you have to go with the differentiation of that f(x), the f of x, so the differentiation will be denoted with f dash x is equals to 0. If you do the integration of this one, you will get f dash x is equals to 0. If you go with the double dash, that one, double differentiation of that one, you will get the minus value, and you can go with f of x is equals to, substitute the value, c is equals to what we have, c is equals to 1 by 2 pi, b is nothing but here sigma only, so that I can write this is 1 by under root 2 pi into sigma into e to the power of 1 by e to the power of minus 1 by 2, minus 1 by 2 is there, x minus a is nothing but it is mu only, x minus a is nothing but mu only, so that x minus mu by b is nothing but sigma, it is whole square. If you do this one, first differentiation, that will be 0, second differentiation obviously you will get that is negative value, so that f of x is maximum at x is equals to mu. Likewise, you can go with the various cases to find the modes of operation of the normal distribution. You have to remember, the point is that the Poisson distribution and the binomial distribution are nothing but it is the discrete distributions, whereas the normal distribution is a continuous distribution. That means what? The random variables are continuously distributed from one point to another point, and from this in this range we are going to calculate the probability density function. The probability density function is denoted with f of x, and during the limits from one point to another point, we are going to calculate that probability density functions, so that these three equations are very, very important. That is about probability density function, this one, and see how can you calculate the constant c value, whereas a and b are the constant. And you may have the doubt is that how the c is constant. C is equals to 1 by under root 2 pi b, and we are choosing the b is a one particular value. If b is constant, obviously c will be constant, because 2 is a constant, pi is nothing but it is a 3.14, it is also constant, and default we are selecting b is also constant, so that we can get the c is also constant. C is a constant and a and b are the parameters, so that after going with some derivations, you can we will be finding that mean mu is equals to a, and the variance sigma is equals to b, and the next one mode is equals to modes of operation will be at the two cases. One is at the x1 and another one is the x2. In calculation of the modes of operation, we have to go with the double integration f dash, and the next one is f double dash. In case of maximum value, you will be getting f double dash is equals to negative value, so that will be the maximum value of f of x at that particular value of x. In the next class, we are going to see some problems in case of normal distribution. With this normal distribution, this second unit will be closed, and so that I am requesting students. So I have already shared the complete 5 units material of the PTSP, so that go through that one, and very soon we will be having, I hope we will be having the online offline classes, and whatever the doubts you have in that online classes, we are going to clear all those doubts. So in tomorrow class, I am going to solve the problems on the normal distribution. Thank you, students. Thank you so much.